Lesson 2.4. We're going to say this is the power rule. All right, so now that we're doing the power rule, we've learned that when we see a base for multiplication, we really just add our exponents. When we see a base for division, we really subtract our exponents. But if you look at this one, do you have a base for this b exponent? Is there a base that goes with the b? No. So when there are not two bases, we have a different rule. What this really means, if we look at example 1, I'm going to move my page down. If we look at example 1, I have 3 to the 6th power squared. What that really means, and we've talked about this, that means 3 to the 6th times 3 to the 6th. Right? That's what that really means. And if you have 3 to the 6th times 3 to the 6th, we learned just a few minutes ago, if you have the base, what do you do with those exponents? You're going to add them. So this is really 3 to the 12th. Is there a way we could have gotten 12 besides doing it this way? Ooh, 6 times 2 at the top. You see that? I could have just done 6 times 2. So if I do 6 times 2, I get 3 to the 12th. That's my answer there. If I look at number 2, 9 to the 4th 4 times, that means I have 9 to the 4th, 9 to the 4th, 9 to the 4th, 9 to the 4th, and I could add each of these exponents, 4 plus 4 plus 4 plus 4, but that gives me what? 16. What's an easier way to do that? 4 times 4 at the top. So I have 9 to the 16th power. So when you don't see a base, notice the difference between these. Okay, shoot. Notice up here, there is no base with this 4. There's no base with this 4, and that means I need to multiply. I added down here because each of these had a base. You guys see that?
Base means there has to be a big number.
Base means a big number, yes. So when you have a base, you add them. If you don't have a base, you multiply. That's the difference. So number 3, it doesn't matter that we have some parentheses going on, right? Because we already talked about what our parentheses means. Do we have a base for that little 3? No. So what do I do with those 2 exponents? Multiply. So Kiesia, what is this going to be on number 3? Negative 3 to the what power? 15th power. Do I need parentheses around this or not?
Yes.
I do, because I have a negative number being raised to a power. All right, let's look at number 4. My base is negative 5. Dulce, what's my exponent going to be? Close. 28. Negative 5 to the 28th power. Lily, do I need parentheses around my negative 5? Yes. Because I have a negative number being raised to an exponent. Try number 5. Mandy, what do we get on 5? 10 to the 6th power. Not 10 to the 5th power, 10 to the 6th power. All right. Correct. You don't need parentheses on that one because it's not a negative number. Okay, let's talk about variable terms. Variable, the rule doesn't change. Stays the same. So on number 7, Chrissy, what's our answer on number 7? X to the 40th power. Doesn't change our rule. Ooh, let's look at number 10. That's a little bit interesting. What do we need to do on number 10, though? Who said that? Mandy, say that louder.
9 times 3 is 2 times 2.
Our 3 is going to both the 9 and the 2. So I have R to the 9 times 3. 9 times 3, folks? 27. Use those multiplication sheets because you can't use a calculator on a test. And S squared to the 3rd power. 2 times 3? S to the 6th. And you need to write them as close together as you can because it's still one answer. Okay, it's not it's not R to the 27th, space, 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 S to the 6th. This is one answer. Okay, why don't you try number 11? Use your multiplication sheet if you need to, but try number 11. Jose, what'd you get for P?
48.
P to the 48th. Haley, what is the Q?
20.
Q to the 20th. Questions on that, folks? All right. Now, what happens when we add coefficients in there? When we add coefficients, we're going to have to go back to what our rules were for coefficients. So, what I'd like for you to do on number 13, if you have 5r all raised to the squared power, that really means, I want you to write this, 5r to the 5th times 5r to the 5th. That's what that really means. 5r to the 5th times 5r to the 5th.
That's a 4.
Oh, wow, what's wrong with me? 5r to the 4th times 5r. I have not drank all my coffee yet this morning. Woo. Okay, if we look back, because I'm a big fan of looking back at our notes, if we look back to the first lesson we did today, what happens when you have a 5 and a 5 like that? What are you supposed to do with them when they're coefficients? Everyone look back. Don't just wait for your classmates to answer. What should you do with that 5 and that 5? What? Multiply. Kiesia says multiply. Anybody agree with the multiply? 3 people in your class agree with you, Kiesia. You should multiply. 5 times 5 gives you 25. What are we doing with our exponents? Can you see a base for both of them? When you see a base, what do? Add them. R to the 8th. Now let's talk about how we get 25r to the 8th by looking at the problem differently. If you look up here, this is like saying 5 squared, because what's the exponent of that 5? What's the hidden exponent of the 5? Remember, there's really a 1 right here. Remember that? So this 2 is 2 times 1, which is 5 squared. And then r to the 8th. But what is 5 squared? 25 r to the 8th. I want you to be able to do it this way, because the second way is going to be a little bit crazy if you have something raised to like the 12th power. You're not going to write that down 12 times. So let's do this process again on 14. On 14, I know this is really 3 to the 4th power. And then what do I do with my exponents for v? What are we going to do with that 3 and that 4? What are we doing with that 3 and 4?
Yeah, I can go.
Do you see a base for this 4? There's no base for that 4. So when there's no base for that 4, what do we do with them?
Multiply.
Multiply. So 3 times 4 is 12. Now, we're not going to leave it as 3 to the 4th because we can figure out what that is. So do a little math. What is 3 to the 4th? Write it down on your paper. I hear an 81. Anyone agree with that? 3 to the 4th is 81? This is 9, right? And then this is 9. 9 times 9. 81. So we have 81 v to the 12th. Yes, ma'am. How did I get 81 again? So are you okay that this is 3 to the 4th? Are you okay that I got 3 to the 4th here?
Oh, yeah.
Okay. And then 3 to the 4th means 3 times 3 times 3 times 3. Are you okay with that so far? 3 times 3 is 9. 3 times 3 again is 9. And then 9 times 9 is 81.
Oh.
Okay. We'll work a little bit more on that. Yes? Try number 15.
Where did 12 come from?
3 times 4. Just like 4 times 2.
But
You
what
missed this
about the
entire
kid?
page because you were out in the hallway.
I had to go talk to Miss Courtney. That was my fault.
So we have 3 to the 3rd. Right? And then k to the what? Yeah. What'd you get? K to the
9.
K to the 9th? Are we getting k to the 9th?
Yes.
Okay. K to the 9th because we multiply 3 times 3. So now we multiplied these 3 times 3 to get k to the 9th, right? But what do I do with this 3 to the 3rd? What does that really mean?
3 times 3.
3 times 3 times 3, right? I have 27 here. 27, 27, 27. So this is really 27 k to the 9th. Try number 16 on your own. Let's all get the same answer.
Whoa. That is a lot.
Wait, let me see that.
I got a question real quick. I know you didn't say get this one, but is this right?
Okay. You have 14x. Remember, this is 12 squared. And I multiply 14 times 2 to get 28 for my x's.
144 to the 28.
Okay, 12 squared, Candace says, is 144. X to the 28th power. 144x 20 to the 28th power. Questions on that? All right, let's turn to our page 14. Let's fill this in for our power rule. So we've already done product rule, we've done quotient rule, power rule. What do we do with this A and B? A times B. That's what we do. So make yourself a note. Multiply the exponents. If you use this chart as you are doing your homework, you should do pretty well. If you don't look back through your notes and you don't look at previous examples and you don't look at this page, you will struggle in your homework and you will not get correct answers. So this is brand new to all of you, so I expect you to be able to be looking at your notes. So because we just did these 3 right here, I'd like for us to go over and do these examples right here. Kind of as a refresher when they're all, oops, not that last one. When they're all on the same page, how do we keep them straight? So when we can see on number 1 up here, I'm in the product rule. When you can see your base, what are you doing with these exponents? adding them, more than one person should have answered that. When you can see your base, you're going to be, guys, you wrote add right here. Okay, so I need you to share with me. You're going to add your exponents. So h to the 8th. Okay, try number 2, based on our rules. And you can look through your notes for examples.
That one to me for a loop.
Try number 2. You know what to do with your exponents at least. Figure out your exponents. Then figure out your coefficients. Do this one, number 2 right here. This one right here. We have a to the 5th, b to the what? 2nd. And what do we do with negative 2 and 7?
Oh, multiply.
We multiply our coefficients. So that should be negative 14. A to the 5th, b to the 2nd.
Do you put parentheses around
Is the 14 being raised to an exponent? No, the 14 doesn't have an exponent with it, so no, you do not need to put parentheses. Okay, let's do that next line. So now we're going to our power rule. What are we doing with our exponents, Datrion? Oh, well, I wrote it down right there. Can you read me on the board? Okay, so what's our x going to be? X to the, thank you, Datrion. X to the 6th power. All right, number 2 is going to require a little bit of work. We know this is negative 2 squared. And then how many m's do we have there? What do we do with these 5 and 2? Multiply. So I have m to the 10th. And then I also have this m to the 3rd thing.
Don't you just add that in?
Would you just add it in?
Well, I mean, since those are the ends, they both have. They both have little numbers above it,
Okay.
so you just add them.
So what Candace is saying is we have a base for each of these, right? And we just learned in the product rule, when you have a base for each of them, you add your exponents together there. So I have, in total, how many m's do I have? 13. I had to do a little bit of work first with this, and then I got there. What is negative 2 squared?
4.
Positive 4, because it's a negative 2 times a negative 2. 4m to the 13th. Good job, Candace. Okay. Quotient rule. What are we doing with our exponents on the quotient rule, Chrissy? What do you do with your exponents in the quotient rule?
Divide.
No?
No, I mean.
Hang on. Chrissy's answering.
Add them? Subtract them?
Did you write this down here?
No.
Okay. Subtract your exponents. So over here, subtracting my exponents, there's that low-key 1 there, right? So if I'm subtracting 5 minus 1, I really have x to the...
4.
Is x to the 4th left on the top, or is it left on the bottom? The top, because that's where there are more of them, right? And then 27 over 42, if I tried to divide that, it would not divide evenly. But 3 can go into both of those. So on your chart, on your multiplication chart, find the 3 column. Find where 27 is. Find where 42 is. Shh. Find where 27 is. Find where 42 is. 27 divided by 3 is 9. And 42 matches up with 14. So this is 9x to the fourth over 14. Do you have any x's that go on the bottom? There were no x's left to go on the bottom, right? Questions on that one? Okay. Number 2 here. Before I can start subtracting my exponents, what do we need to do first? I need to take care of this right here, right? And I'm going to multiply, because this is a power. I don't have a variable for that 2 on the outside. So 2 times 2 is, so this is really y to the fourth over y to the fourth. And then what do we do with our exponents? They cancel each other out. What's 4 minus 4? 0. So is my answer 0? Is it just y? If it's just y, don't we have a hidden exponent here, which is what? Is it y to the first? We know it's not y to the first. What is, guys, if you have 8 divided by 8, what is 8 divided by 8? 1. What is 10 divided by 10? What is 29 divided by 29? Anything is 1 if you divide it by itself. So what is y to the fourth divided by y to the fourth? 1. What is 4 minus 4? What do we say 4 minus 4 was? So here's another exponent rule that we didn't talk about. It's really y to the 0, and anytime you raise a variable to a 0 power, you get the number 1. Woo! That was for free. We'll talk about that tomorrow. On page 13, I have 8 questions for you to do. On page 13, there are 8 questions. Don't do the ones at the top. On page 13, there are 8 questions, starting at number 23. You need to work slowly through these. Do not try to rush. Remember your rules. I'll help you get started on number 8. You're supposed to be using your packet, not number 8, sorry, number 23. Okay. You have a lot of space in your box there. Please use it. On 23, we're going to look at this monomial first. Okay, we're not even going to pay attention to the 3x to the 6th yet. Is there a base for this 4? So when there is no base, what are you supposed to do with your exponents? Okay. What I should have heard in the room was a bunch of papers flipping so you could look back and look at things. Do not just sit there and wait for the answer. That's not effective learning. Also, just scrolling through papers just to make paper noise is also not helpful. Okay. We have to, when we do not have a base here for this 4, we have to multiply exponents. So this is negative 2 to the fourth. And then what do we do with that 3 and 4? Multiply. 3 times 4, 12. What did I forget to do in my paper? Around what?
Negative 2. Because it's being raised.
Okay. Can you see a base for both of these x's? Do they have a base? Do they have a variable?
Mm-hmm.
So when you can see a base, You're supposed to add your exponents. Before you take care of your coefficients, you're going to have to take care of this guy first before you do anything with the 3. Okay? I'm going to leave you from there. You have your packet, you have your neighbor, and I'll be walking around. So you need to do these 8 problems for homework.